Hey everyone, and welcome back to the channel. Today, we're diving deep into something truly revolutionary for almond growers, using advanced drone and satellite technology, specifically something called the Normalized Difference Red Edge, or NDRE, to literally unlock the hidden secrets of your orchard. Now, you might have heard of NDVI, the Normalized Difference Vegetation Index. It's a classic for measuring plant health. But for dense, multi-layered crops like almond trees, NDVI has a big limitation: it gets saturated. It hits its maximum value quickly, and then it can't tell you if the tree is getting even healthier or, more critically, if it's experiencing stress deep within its canopy. That's where NDRE comes in. NDRE uses a different part of the light spectrum, the red edge band. Think of it like this. Red light is mostly absorbed by the very top layer of leaves. But red edge light penetrates deeper into the canopy, giving us a more complete picture of the total chlorophyll content and nitrogen status of the entire tree. This is absolutely crucial for complex perennial crops like almonds, especially as they mature. The formula for NDRE is NIR reed edge, NIR plus reed edge, giving us a value between -1 and +1. Generally, low values mean bare soil or unhealthy plants, while high values, typically 0.6 to 1.0, indicate healthy, dense vegetation. So why is this important? Because a slight drop in NDRE can be the earliest sign of trouble. Issues like nutrient deficiencies, water stress, or even the beginnings of a pest or disease problem. And catching those issues early, well, that's where you save big on inputs and protect your yield. Now, the amazing thing about NDRE in almond orchards is that what constitutes healthy isn't static. It changes dramatically over the almond tree's 30-year lifespan, and even throughout a single season. An AI model trying to understand your orchard needs to know this dynamic baseline. Let's break it down. Years 1, 4, the young and growing orchard. In these early years, an area averaged NDRE value will steadily increase. Why? Because the trees are rapidly expanding their canopy, and more of the ground is being covered by healthy foliage. So, a healthy 2-year-old might have a peak NDRE of 0.3-0.4, but by year 4 it could be 0.5, 0.6. An AI needs to know the orchard's age to correctly interpret these values. Years 5, 25, the productive prime. This is when your orchard reaches full canopy cover and stabilizes. Your healthy, mature trees should show consistently high NDRE values, typically in the 0.6 to 0.85 range, during the main growing season. Any significant drops here are a red flag for stress. Years 26 plus, the aging orchard. Just like us, trees get older. You'll likely see a slow, long-term decrease in average NDRE as the trees naturally senesce. An AI needs to differentiate this gradual decline from sudden drops caused by acute problems. And it's not just about age, it's also about the season. An almond tree's NDRE value follows a predictable path throughout the year. Dormancy to early spring, winter to March-April. Low NDRE, lots of bare branches. As leaves emerge, values rise sharply. Late spring to early summer, May-July. This is your peak vegetative growth. NDRE values hit their seasonal maximum. This is the ideal time to get a baseline health signature. Midsummer to harvest, July-August. As the tree focuses on kernel development, NDRE might slightly decline. You might even intentionally induce a slight water stress during hull split for hull rot management, which would show up as a controlled NDRE drop. Post-harvest and senescence, September-October, leaves yellow as nutrients are remobilized and NDRE rapidly declines until leaf fall. Understanding these age and seasonal curves is absolutely essential for an AI to accurately tell you if something is truly wrong, or if it's just a normal part of the tree's life cycle. This is where the real power of NDRE, combined with artificial intelligence, shines. It's about translating a spectral signal into a specific agronomic problem. 1. Nitrogen N. Status. This is one of the most established uses of NDRE. Nitrogen is a key component of chlorophyll. Less chlorophyll means less absorption in the red edge, which means lower NDRE. If your trees are N deficient, your NDRE will be lower. This allows for precision fertilization, saving you money and reducing environmental impact. But remember, NDRE is a qualitative indicator. For exact nitrogen percentages, you still need lab leaf tissue analysis. Also, too much nitrogen can be bad too, increasing susceptibility to diseases like hull rot. So an unusually high NDRE late in the season can also be a warning. 2. Water stress. Almond trees respond to water stress by closing their stomata and, if severe, by degrading chlorophyll. Both lead to a lower NDRE. NDRE can give you an early warning, often before visible symptoms like wilting appear. But for the most accurate water stress diagnosis, AI models combine NDRE with other indices. For example, the Crop Water Stress Index, CWSI, which uses thermal cameras to measure canopy temperature, or the Normalized Difference Water Index, NDWI, which directly measures water in the leaf. When you see a low NDRE and a high CWSI and a low NDWI, that's a confident diagnosis of water stress. The gold standard for ground truthing water stress: midday stem water potential, SWP, measurements with a pressure chamber. 3. Pest and disease infestation. NDRE doesn't directly see a bug or a fungus. What it does see is the plant's response to that attack. The spatial pattern of the NDRE anomaly is often as important as the value itself. Take hull rot, for example. This fungal disease causes shoot strike, a sudden death of leaves on individual branches. On a multispectral image, this shows up as a sharp, localized drop in NDRE, a clear contrast against the healthy green. An AI can be trained to spot these distinct patterns, or Phytophthora root and crown rot. This soil-borne mold attacks the roots. Chronic infections lead,